Learning objectives. In this chapter, the user will learn the following in detail: integrated development environment, debugging, tracing, data inspection, exception errors, code and data redundancy, unreachable code. Code redundancy. Redundant code is source code or compiled code in a computer program that is unnecessary. Recomputing a value that has previously been calculated and is still available, or code that is never executed, known as unreachable code, or code which is executed but has no external effect, known as dead code. An example is shown on screen. The second ix into 2 expression is redundant code and can be replaced by a reference to the variable iy. Alternatively, the definition int iy equals ix into 2 can instead be removed, because the use of min-max macros is very common. Modern compilers are trained to recognize and eliminate redundancy. Data redundancy. Data redundancy is the repetition of data. Data redundancy is a common issue in computers' data storage and database systems. Data redundancy in database means that some data fields are repeated in the database. This data repetition may occur either if a field is repeated in 2 or more tables or if the field is repeated within the table. Data can appear multiple times in a database for a variety of reasons. For example, a shop may have the same customer name appearing several times if that customer has bought several different products at different dates. Data redundancy is a condition created within a database or data storage technology in which the same piece of data is held in 2 separate places. This can mean 2 different fields within a single database or 2 different spots in multiple software environments or platforms. Whenever data is repeated, this basically constitutes data redundancy. This can occur by accident, but is also done deliberately for backup and recovery purposes. Within the general definition of data redundancy, there are different classifications based on what is considered appropriate in database management and what is considered excessive or wasteful. Wasteful data redundancy generally occurs when a given piece of data does not have to be repeated but ends up being duplicated due to inefficient coding or process complexity. A positive type of data redundancy works to safeguard data and promote consistency. Many developers consider it acceptable for data to be stored in multiple places. The key is to have a central master field or space for this data, so that there is a way to update all of the places where data is redundant through one central access point. Otherwise, data redundancy can lead to big problems with data inconsistency, where one update does not automatically update another field. As a result, pieces of data that are supposed to be identical end up having different values. Disadvantages of data redundancy: increases the size of the database unnecessarily, causes data inconsistency, decreases efficiency of database, may cause data corruption. Debugging is all about data inspection. What are the local variables? What is in memory? What is the code flow? Visual Studio Data Inspection. Visual Studio offers great data inspection features: watch windows, autos and locals, memory and registers, data tips, immediate window. Watch window allows you to inspect various states of your application. Several different kinds of predefined watch windows: autos, locals, custom watch windows also possible. Contains only variables that you choose to add. Right-click on the variable and select Add to Watch. Autos and locals. Locals watch window contains the local variables for the specific stack frame. Debug, Windows, locals. Displays a name of the variable, value and type. Allows drill down into objects by clicking on the plus sign in the tree control. Autos lets the debugger decide which variables to show in the window, loosely based on the current and previous statement. Memory and registers. Memory window can be used to inspect process-wide memory. Address field can be a raw pointer or an expression. Drag and drop a variable from the source window. Number of columns displayed can be configured. Data format can be configured. Registers window can be used to inspect process registers. Data tips. Provides information about variables. Variables must be within scope of current execution. Place mouse pointer over any variable. Variables can be expanded by using the plus sign. Pinning the data tip causes it to always stay open. Comments can be added to data tips. Data tips support drag and drop, importing and exporting data tips. Immediate window. Useful when debugging due to the expansive expressions that can be executed. To output the value of a variable, name of variable. To set values, use name of variable equals value. To call a method, use name of variable, method, arguments. Similar to regular code, supports IntelliSense. What is debugging? Debugging is the process of identifying errors in a program code and then fixing them up. Debugging approaches. Some of the approaches popularly adopted by programmers for debugging: brute force method, backtracking, cost elimination method, program slicing. Brute force method. This is the most common method of debugging, but it is the least efficient method. In this approach, the program is loaded with print statements to print the intermediate values with the hope that some of the printed values will help to identify the statement in error. This approach becomes more systematic with the use of a symbolic debugger because values of different variables can be easily checked and breakpoints and watch points can be easily set to test the values of variables effortlessly. Brute force method involves using the debugger to step across the code from start to finish until you notice something odd. Then you start over and step through the code again, looking for the source of that oddity. When you reach the end and don't see the source of the problem, you start over and step through the code once more, over and over again until the bug is fixed. Backtracking. This is also a fairly common approach. In this approach, beginning from the statement at which an error symptom has been observed, the source code is traced backwards until the error is discovered. Unfortunately, as the number of source lines to be traced back increases, the number of potential backward paths increases and may become unmanageably large, thus limiting the use of this approach. Cost elimination method. In this approach, a list of causes which could possibly have contributed to the error symptom is developed and tests are conducted to eliminate each. A related technique of identification of the error from the error symptom is a software fault tree analysis. Program slicing. This technique is similar to backtracking. Here the search space is reduced by defining slices. A slice of a program for a particular variable at a particular statement is a set of source lines preceding the statement that can influence the value of that variable. Debugging guidelines. Debugging is often carried out by programmers. Hence, those involved in debugging should understand all the causes of an error before starting with debugging. No experimentation should be done while performing debugging. The experimental changes, instead of removing errors, often increase the problem by adding new errors in it. When there is an error in one segment of a program, there is high possibility that some other errors also exist in the program. Hence, if an error is found in one segment of a program, rest of the program should be properly examined for errors. It should be ensured that the new code added in a program to fix errors is correct and is not introducing any new error in it. Thus, to verify the correctness of a new code and to ensure that no new errors are introduced, regression testing should be performed. Many times, debugging requires a thorough understanding of the program design. Trying to debug based on a partial understanding of the system design and implementation may require an inordinate amount of effort to be put into debugging even simple problems. Debugging may sometimes even require full redesign of the system. In such cases, a common mistake that novice programmers often make is attempting not to fix the error but its symptoms. One must beware of the possibility that an error correction may introduce new errors. Therefore, after every round of error fixing, regression testing must be carried out. It is not testing, but it always occurs as a consequence of testing. The process of locating and fixing or bypassing bugs or errors in a computer program code. To debug a program, start with the problem, isolate the source of the problem, fix it. Debugging tools, also called debuggers, help to identify coding errors at various development stages. Debugging is defined as the process of analyzing and removing the error. It is considered necessary in most of the newly developed software or hardware and in commercial products and personal application programs. For complex products, debugging is done at all the levels of testing. Debugging is considered to be a complex and time-consuming process since it attempts to remove errors at all the levels of testing. To perform debugging, debugger is used to reproduce the conditions in which failure occurred, examine the program state, and locate the cause. With the help of a debugger, programmers trace the program execution step by step and halt the execution wherever required to reset the program variables. Note that some programming language packages include a debugger for checking the code for errors while it is being written. To debug the problem, a number of steps are followed. Defect confirmation, identification. A problem is identified in a system and a defect report created. A software engineer maintains and analyzes this error report and finds solutions to the following questions. Does a defect exist in the system? Can the defect be reproduced? What is the expected desired behavior of the system? What is the actual behavior? Defect analysis. If the defect is genuine, the next step is to understand the root cause of the problem. Generally, engineers debug by starting a debugging tool, and they try to understand the root cause of the problem by following a step-by-step execution of the program. Defect resolution. Once the root cause of a problem is identified, the error can be resolved by making an appropriate change to the system by fixing the problem. When the debugging process ends, the software is retested to ensure that no errors are left undetected. Moreover, it checks that no new errors are introduced in the software while making some changes to it during the debugging process. Debugging process. Debugging occurs as a consequence of successful testing. The debugging process begins with the execution of a test case. Results are assessed and the difference between expected and actual performance is encountered. This difference is a symptom of an underlying cause that lies hidden. The debugging process attempts to match symptom with cause, thereby leading to error correction. A debugging algorithm for software engineers. Identify test cases that reliably show existence of fault. Isolate problem to small fragments of a program. Correlate incorrect behavior with program logic code error. Change the program and check for other parts of the program where same or similar program logic may also occur. Regression test to verify that the error has already been removed without inserting new errors. Update documentation when appropriate. Why is debugging so difficult? The symptom and the cause may be geographically remote. The symptom may disappear temporarily when another error is corrected. The symptom may actually be caused by non-errors. The symptom may be caused by human error that is not easily traced. Bug may be triggered by rare or difficult to reproduce input sequence, program threads, or other external causes. Debugging by testing. This debugging method can be used in conjunction with debugging by induction and debugging by deduction methods. Additional test cases are designed that help in obtaining information to devise and prove a hypothesis in induction method and to eliminate the invalid cases and refine the hypothesis in deduction method. Note that the test cases used in debugging are different from the test cases used in testing process. Here, the test cases are specifically designed to explore the internal program state. What is a debugger? A debugger is part of an IDE, a software tool that is used to detect the source of program or script errors by performing step-by-step execution of the application code and viewing the content of code variables. Though the two can be integrated, they are separate entities. A debugger loads in a program, compiled executable or interpreted source code, and allows the user to trace through the execution. Debuggers typically can do disassembly, stack traces, expression watches, and more. Why use a debugger? Flexible. Allows for live error checking. No need to rewrite and recompile when you realize a certain type of error may be occurring. Dynamic. Can view the entire relevant scope. Debugging and testing. Testing, debugging cycle. Test, then debug, then repeat. Any debugging should be followed by a reapplication of all relevant tests, particularly regression tests. This reduces the introduction of new bugs when debugging. Testing and debugging need not be done by the same people. Designing for debug test. When you write code, think about how you're going to debug it. Lack of thought always translates into bugs. Write test cases when you write your code. If something should be true, assert of it. Create functions to help visualize your data. Design for testing, debugging from the start. Test early, test often. Test at abstraction boundaries. Exception is an event which occurs during the execution of a program that disrupts the normal flow of the program's instructions. When an error occurs within a method, the method creates an object and hands it off to the runtime system. Example, exception handling using DBX. A program stops running if an exception occurs. Exceptions signal programming anomalies such as division by zero or array overflow. You can set up blocks to catch exceptions raised by expressions elsewhere in the code. While debugging a program, DBX enables you to catch unhandled exceptions before stack unwinding, catch unexpected exceptions, catch specific exceptions whether handled or not before stack unwinding, determine where a specific exception would be caught if it occurred at a particular point in the program. If you give a step command after stopping at a point where an exception is thrown, control is returned at the start of the first destructor executed during stack unwinding. If you step out of a destructor executed during stack unwinding, control is returned at the start of the next destructor. When all destructors have been executed, a step command brings you to the catch block handling the throwing of the exception. Commands for handling exceptions. Exception -d plus or minus d command. Use the exception command to display an exceptions type at any time during debugging. If you use the exception command without an option, the type shown is determined by the setting of the DBX environment variable output dynamic type. If it is set to on, the derived type is shown. If it is set to off, the default, the static type is shown. Specifying the -d or +d option overrides the setting of the environment variable. If you specify -d, the derived type is shown. If you specify +d, the static type is shown. DBX intercept all x int. To intercept exceptions of type error, you would type DBX intercept error. After intercepting too many common error exceptions, you could exclude these exceptions by typing DBX intercept x common error. Typing the intercept command with no arguments would then show that the intercept list includes unhandled exceptions and unexpected exceptions, which are intercepted by default, plus exceptions of class error except for those of class common error. DBX intercept, unhandled, unexpected, class error, x class common error. If you then realize that error is not the class of exceptions that interests you, but you do not know the name of the exception class you're looking for, you could try intercepting all exceptions except those of class error by typing DBX intercept all x error. Unintercept all x type name command. Use the unintercept command to remove exception types from the intercept list or the excluded list. Use the command with no arguments to list the types that are being intercepted. Use all to remove all types from the intercept list. Use type name to remove a type from the intercept list. Use X to remove a type from the excluded list. Who catches type name command? The who-catches command reports where an exception of type name would be caught if thrown at the current point of execution. Use this command to find out what would happen if an exception were thrown from the top frame of the stack. The line number, function name, and frame number of the catch clause that would catch type name are displayed. The command returns type is unhandled if the catch point is in the same function that is doing the throw. Examples of exception handling. This example demonstrates how exception handling is done in DBX using a sample program containing exceptions. An exception thrown in the function bar and is caught in the following catch block. Integrated Development Environment (IDE). Integrated Development Environment is a software application that provides a programming environment to streamline developing and debugging software. Rather than performing all the steps required to make an executable program as unrelated individual tasks, it brings all the tools needed into one application and workspace. Each of the tools has an awareness of the environment, and they work together to present a seamless development set for the developer. Even a simple search for IDEs will turn up quite a few choices. IDEs are available from open source communities, vendors, and software companies. They range from free to pricing dependent upon the number of licenses required. There isn't a standard for IDEs, and each has its own capabilities along with strengths and weaknesses. Generally, an IDE provides an easy-to-use interface, automates development steps, and allows developers to run and debug programs all from one screen. It can also provide the link from a development operating system to an application target platform like a desktop environment, smartphone, or microprocessor. For example, Selenium IDE. Selenium IDE is a prototyping tool for building test scripts. It is a Firefox plugin and provides an easy-to-use interface for developing automated tests. Selenium IDE has a recording feature which records user actions as they are performed and then exports them as a reusable script in one of the many programming languages that can be later executed. Selenium Test Package. Selenium is a package of various test components which consists of the following three major tools. Each one has a specific role in aiding the development of test automation for a web application. Selenium IDE, a Firefox extension to record test cases and suites. Selenium RC, used to run tests on different browsers and systems. Selenium Grid runs multiple instances of Selenium RC at once. Qualitia and Tellurium, a wrapper for the Selenium engine. Selenium modes. Selenium has following three modes for executing the test cases and test suites. Record playback mode, Selenium IDE. In this mode, only Selenium IDE is used to record the test scenarios in terms of test cases in Firefox. This is a great way to get started to writing tests and grouping them together to form the test suite. The recorded tests can be exported to many programming languages so that we can put them in the testing framework. The test cases and test suites can be replayed back to check the verifications and validations or sent to Selenium RC. Selenium Remote Control RC mode. In this mode, Selenium starts multiple browsers and then runs the recorded test cases which are saved in your language of choice. This helps to enhance the test cases with looping and programming techniques to cover all the required test scenarios and checks. Test Runner mode. In this mode, the test cases are recorded and replayed in the form of HTML tables. This is to execute the Selenium IDE as well as RC test cases. This helps to check the test results reports in a better manner if not formatted already. Software development steps. To develop an executable software, you need to create source files, compile the source files to produce machine code object files, and link the object files with each other and any libraries or other resources required to produce an executable file. Source files contain the code statements to do the tasks. They contain program statements specific to the language you are using. If programming in C, the source file contains C code statements. Java source files contain Java statements. Usually, source file names have extensions indicating the code they contain. C source file may be named myfile.c. Compilers translate the source files to appropriate machine-level code for the target environment. Linkers take all the object files required for a program and link them together, assigning memory and registers to variables, setting up data. They also link in library files to support operating system tasks and any other files the program needs. Linkers output executable files. Coding and debugging using IDEs. Bringing up an IDE presents a workspace. This is the Dev C++ 5.11 IDE. With an IDE, a project provides a workspace where all the files for a program can be collected. Select the language and the type of program to create. This IDE supports C and C++ and various application types. If set for a Windows application in C, it brings up a template. A console C program brings up a different template. Depending on the IDE, it may set up code blocks automatically, indent as required, track variable names in colors, show comments. To compile, just click the Compile selection on the drop-down menu or press F9. As source files are created, they are added to the project. The Rebuild selection rebuilds all the files, first checking for the latest versions, then compiles and links to produce an executable result. Errors on the compile or link. The offending code will be shown in the code window. The statement containing the error or the lines around it is known, since the compiler, linker, and editor are seamlessly connected and run the executable from the IDE by selecting Run. The results show in a separate window. Problems when running your new program? Usually IDEs provide an option to create a debug version. With a debug version, the IDE controls the execution of the program, allowing insight to data variables and memory locations. Some IDEs show both the high-level source statements as well as the machine code. The debugger may include options to watch local variables and track the contents of memory locations, offer line-by-line execution, provide the ability to set breakpoints to run to a certain point in the program, and the ability to step into or over function calls. Some IDEs include emulators, allowing debugging in the IDE environment without having to export the code to the target device. Tool chain applies to a related set of development tools: a builder, compiler, linker, and debugger. The builder tells the compiler the files and options to use, and the linker and debugger are connected. An IDE includes these as well as an editor and other tools. Choosing an IDE. When selecting an IDE, you will find there are a lot to choose from, and the price can vary from no cost to pricing options dependent on the environment and number of users. The license type is important as well if you intend to produce commercial code. Some things to check to choose IDE. Does it provide support for your development platform, programming languages, target environments? Capabilities. What is included? Does it have watch points for debugging? Can it single step through code? Do you need to see the low-level language used, or is source code debugging good enough? Pricing and licensing. Are you looking for a supported environment and willing to pay for it? Does your company need several licenses? Are there royalties required? Are there fees per use? Just as the IDE in these examples brought up template code blocks for certain applications, there are IDEs that support specific microcontrollers. These specialized IDEs automatically set up some code for the microcontroller. IDE makes software development and debugging easier by providing a single development workspace containing all the tools needed for development. It tracks files automatically and saves time. Choosing one suited to your programming need makes developing and debugging software much easier. Debugging techniques. Tracing. Tracing collects information about what is happening in your program and displays it. If a program arrives at a breakpoint created with a trace command, the program halts and an event-specific trace information line is emitted, then the program continues. A trace displays each line of source code as it is about to be executed. A more useful trace applies a filter to display information about events in your program. For example, you can trace each call to a function, every member function of a given name, every function in a class or each exit from a function. You can also trace changes to a variable. Example, tracing execution with dbx debugger. Setting a trace. Set a trace by typing a trace command at the command line. The basic syntax of the trace command is trace event specification modifier. The information a trace provides depends on the type of event associated with it. Controlling the speed of a trace. The dbx environment variable trace speed lets you control the delay after each trace is printed. The default delay is 0.5 seconds. To set the interval in seconds between execution of each line of code during a trace, type dbx-env trace speed number. Execution tracing. Running the program, print, trace utilities, single-stepping in debugger, hand simulation. Directing trace output to your file. Direct the output of a trace to a file using the file name option. For example, the following command directs trace output to the file trace1. dbx trace file trace1. To revert trace output to a standard output, use for file name. Trace output is always appended to file name. It is flushed whenever dbx prompts and when the application has exited. The file name is always reopened on a new run or resumption after each attach. Execution tracing follows the program through the execution. Users can step through line by line or use breakpoints. Typically allows for watches on, registers, memory locations, symbols. Allows for tracing up the stack of runtime errors, backtraces. Allows user to trace the causes of unexpected behavior and fix them. What is unreachable code? Unreachable code, a part of the source code that will never be executed due to inappropriate exit points, control flow. The other kind of unreachable code is referred to as dead code, although dead code might get executed but has no effect on the functionality of the system. An example is shown on screen. Unreachable code side effects: unnecessary memory overheads, unnecessary caching cycles, which leads to performance bottlenecks, documenting and maintaining overheads. Unreachable code causes: programming errors while developing complex conditional branches, incomplete unit testing because of which unreachable code was undetected, redundant code that developer forgot to delete, the code that might be programmatically correct but won't be executed at any point of time due to the input data that is passed to the function. Conclusion. In this chapter, we have covered the following in detail: integrated development environment, debugging, tracing, data inspection, exception errors, code and data redundancy, unreachable code.